Okay, chapter P should be a like warm-up chapter for us. It's called a prerequisite chapter. It's there to like help us get back in the swing of things and learn some stuff. Some of you are going to be extremely bored. Some of you might struggle a little. That's okay. What was it?
I'll just raise my hand.
Oh, about struggling. Okay. But this lesson that we're going to do today, P1, this is only part of the lesson. Most of the lessons in this book have 10 to 20 examples in it. So most of the lessons are going to take us 2 days to get through. Understood? It starts on page 2. Okay? And I do want you to have a textbook open next to you, because there are boxes of information I did not write up here that I want you to look at with me. So page 2, you can share a textbook, it's okay, as long as your neighbor's nice. But maybe you should actually bring your supplies to class every day. Okay. Focus. We got a lot to get through. Okay, so P1 starts with real numbers. We have rational and we have irrational numbers. Rational numbers are when it can be written in a ratio form, like a fraction, like P over Q, where Q does not equal 0. 1/3 is a rational number. 0.125 can be written into a rational form of 1/8. Do you see what I'm saying? Anything that comes out like a fraction that works. Okay? An irrational number is a real number that cannot be written as the ratio of 2 integers. What is radical 2? What is radical 2? If you want to plug it into your calculator, you're going to press second and then x squared and then 2.
1.41.
1.4142135562. Nothing repeats, nothing changes. I can't put that into a fraction. Okay? So it is irrational. Pi. What does pi represent?
3.14.
3.14. It's irrational. Okay? So we can have numbers, we can have symbols, we can have radicals as irrational. Rational we can have as fraction form. Okay? We need to know the difference between those two things, depending on what it's asking. On page 2, there's also a diagram that breaks down all types of numbers. And it's written like little square boxes. And it says real numbers. And then it breaks off into real numbers are rational numbers and irrational numbers. Do you see that box? So you have real numbers, okay? And real numbers break down into rational and irrational, right? Okay. Irrational is what we just talked about. And rational. Okay? Rational, though, has more categories, okay? It has non-integer fractions, positive and negatives, and it has integers. Non-integers and integers, okay? A non-integer fraction, I guess is how I want to say, okay? That doesn't go any further, but integers go further. Integers go into whole numbers and into negative integers. Okay? Whole numbers break down into natural numbers and into 0. So there are lots of subcategories for numbers. Okay? It all starts, the over-encompassing term is real numbers. Everything is a real number. That is not imaginary, right? Okay. Real numbers break down into irrational and rational. The difference between irrational and rational is that rationals can be written in a ratio form. Meaning the number 8 can be written in a rational form. What would it be like? 8 over 1. Okay. Rational numbers then break down into integers and non-integer fractions. Okay. And then integers break down into negative and whole numbers, and whole numbers break down into natural whole numbers, and the number 0 is its own category. Okay. So who knew there were so many categories in numbers? Okay. So then we are going to go into describing subsets of numbers. Okay? Subsets. These are subsets. Okay? Okay, so we're going to go into describing subsets of real numbers and representing them on number lines. Remember how to do number lines?
That's easy.
That's easy? Good. So how do I describe the subset of real numbers that the inequality represents? X is greater than or equal to 2. How do I represent that?
You gotta draw your number line.
Gotta draw my number line. Then what, how do I go from here?
You put a line on, put dot on.
Oh, we are not using, no, we are not using dots. We're
Oh,
going to use,
brackets.
there we go.
See,
Let's be more sophisticated, we'll use brackets. So I have a bracket, okay, because I have greater than or equal to, and which way is my bracket facing?
X is greater.
Beautiful. And then what do I do from there?
Draw your line.
That way.
Boom.
Yeah,
Okay,
definitely.
perfect. Down here, I have x is greater than -1, so what do I need?
A parenthesis.
A parenthesis, beautiful.
Okay there, Alex.
I'm sorry.
Don't apologize. We should apologize.
So I need a parenthesis, which way does it face, left or right?
X is
Right.
bigger than.
Right. Parenthesis, wiggly line.
Wiggle right.
There we go. How do I do -2 is less than or equal to x, x is less than or equal to 3?
You need a big number line. Is it boring to you? Please.
Okay, where do I start? -2 is less than or equal to x, what do I do there?
Put your bracket on -2.
Put my bracket at -2, which way does it face?
X is bigger than, so, right.
Yep. Now I have x is less than or equal to 3,
Bracket on 3,
and which way does it face?
left.
And I shaded B. Okay, so first thing we're gonna do is putting things like that on number lines. Can we handle that?
I think so.
I think we can.
I hope so.
Or you can handle it. She said I'll attempt it. Okay, so that is what it's asking when it says represent these in subsets. Ugh, I can't talk, that'd be nice. In subsets, okay? That's what it's asking for us to do. If you look on page 3, there is a bounded intervals on the real number line box, okay? And it breaks things down. If the notation form is AB and it's 2 brackets, that's called a closed interval. So if I have 2 brackets, this is closed, okay? Because it can only contain the numbers in between those 2 sections. It's closed, okay? If I have 2 sets of parentheses, that's considered open. Especially if there's an infinity in one of those sides, because it's gonna go on forever, okay? So I have an open situation, okay?
What did you just say?
If there's an infinity inside of this, it's for, yeah, well, if there's 2 parentheses, it's always open. But if there's infinities inside, it's because it's going to continue on forever, for sure. If I have a bracket, then a parenthesis, okay, there is no classification for this. Okay, we don't call it closed, we don't call it open. In our minds, it's basically just neutral. Okay, and if I have a parenthesis and then a bracket, there also is no classification for that. Okay, all we need to know is 2 brackets are closed, 2 parentheses mean open. Okay. Now, things change when we add infinity signs into here. That's if we have numbers, okay, in both sections. If I have a bracket, well, if I could draw, that would be good. If I have a bracket and then an infinity, infinity is always followed by a parenthesis, okay? If I have a bracket then an infinity, I don't have a classification there, okay? If I have 2 parentheses, what is my classification?
Open.
Open. And it doesn't matter what that looks like, just if I have 2, it's open, okay? If I have a parenthesis and then a bracket again, let's say I have a negative infinity and then a bracket here, there's still no classification because it's only a parenthesis and a bracket. It's not both, okay?
Gotta be one of you.
If I have a negative infinity forever here, and I have a number here, but I have two parentheses, what is it? Open. Okay? Do you see what I'm doing here? Okay?
So it's just two brackets and closed.
And then, well, on this, whenever you're dealing with infinities, you're never gonna have two brackets. Because an infinity always has a parenthesis with it. So if an infinity is involved, there's never brackets, two brackets. And then if I have a negative infinity and a positive infinity, okay, this has its own classification. Its entire real line is the interval type, entire real line.
That's so lame when they do this.
I know, right? Entire real line. Okay, so when I have negative infinity and positive infinity, I have an entire real line, which is common sense because it's continuing on forever in both directions. Okay, then we want to use inequality notation to represent each of the following. How can I use inequality notation to represent each of the following? What do you think I can do? This statement says what?
C is at most two.
Okay, meaning C is what?
C is two or less.
C is less than or equal to 2, okay? That is how I write it in this form. Now I need to write it into interval notation, meaning with brackets and parentheses. How do you write C is less than or equal to 2 with brackets or parentheses? How would you write that? I want to do it both ways. We're going to practice both ways.
Well, when you use
Do you use two brackets? I have a question. Do you use two brackets when you do something like that?
Two brackets. No, one bracket.
One bracket, because if I put it to, I'd have to put it to a number line basically, right?
Yeah.
And so I would have a bracket going in which direction?
The left, yeah, that.
Yeah, that way. Okay, so if I wrote this, basically if 2 is here, right? I have a bracket facing this way because it can be anything like this. So it goes on forever down here, meaning what symbol do I use to show that it goes on forever?
Infinity.
Negative infinity. And that always includes a parenthesis, yes? And then you're gonna say 2 with a bracket. And the reason I put the bracket there is because it can be 2, but it doesn't have to be 2. It can be any number less than 2.
Is
Yes.
infinity always gonna have a parenthesis?
Affinity always has a parenthesis.
Okay.
Okay? So this is how I write it in, this is how I write it in inequality notation. This is how I write it in notation form.
Is
Okay?
a negative infinity always going to be in the x position?
No. You'll have to decide. Because this is facing this way, it's gonna go on into negative forever, okay? If it was facing the other way, I would have positive, like I would have, it would be flipped. Okay, so I get what you're saying.
Yeah.
You're calling this x and this y, yes? Okay, so yes, if a negative shows up, it's always in the x spot. Okay. Okay. How do you write part B? All x in the interval -3, 5.
Well, we know that the bracket's gonna be facing that way, right?
They technically already gave us this right here, yes? Okay, so you're right, the bracket's like this, or the bracket faces this way,
So
the
it's gonna be
parenthesis
at
faces
5,
that way.
facing that way.
So if I graphed this on a number line, right, I would have -3 here, I'd have 5 here, and it would look something like this, right? How do you write that in this form? In inequality notation form?
Negative.
It's less than or equal to 5.
Okay, -3,
Oh, that's
it's
uh-huh,
greater than or equal
less
to 5.
less than or equal to, right, is it what, wait, -3, and I'm going that way, right? Now listen, it's not less than or equal to, it's just less than. Why is it just less than? No, because what is this? A parenthesis. And parentheses on my number line represent less than or greater than. If I have a bracket, I have less than or equal to or greater than or equal to. Okay, so -3 is less than, and they said x is the variable we're using. And then how do I represent this? How does x compare to this 5 when I graph it? Yes, it's less than or equal to 5. There is my inequality notation. You gotta take it one step at a time. Okay? So how I did that was, for me, I'm do better when I graph it, because then I can see it and I can think, like, what makes sense. Okay? So after I graphed it, I realized this is a parenthesis, so that has to say less than, because it's not going this way. Okay?
Why is -3 less than x?
Because it's never going to cross into -3. X is greater than -3, correct? Like if I look here, my x is gonna fall higher than -3, yes? Okay, so that means that -3 is less than when I write it in that order. Does that make sense? Okay. Now, t is at least 4, but less than 11. T is at least 4, but less than 11.
So, are we writing, which way?
Okay, put t in the middle. Good, Jeremiah, that's a good start.
Which way are we writing it?
That's a good we wanna write it in this form.
Oh, okay.
Oh, wait, I have an idea. Is it t is less than or equal to 4, then 4 is less than 11?
It'd be greater than
That's what I meant, less than or equal to 4. It has to be at least 4. But less
No,
than
it would be 4 is less than or equal to t, which is less than
Okay,
11.
so if I graph this, right, we know that 4 is smaller than 11, yeah? So we're working with something in between there. If I look at t is at least 4. What does that mean? It can be the number 4 or it can be
It's greater than or
greater
equal
than,
to 4.
right? So I would have a bracket there, right? Because it can be 4, but it also can be bigger. But then it says it's less than 11, so what does that mean? I have a parenthesis here. So if I graphed it, that's what it would look like, yes? So then I put a 4 here, I put 11 here, what signs go here?
Greater than or equal to and less.
Greater than or equal to, but there and then less than.
And then
No,
less,
other way.
Other way.
other way?
The
Yeah.
4.
No, the other
four.
one, the 4, yeah.
Good. Okay, so 4 is less than or equal to t, and t is less than or equal to 11, yes?
C.
No.
Does that make sense?
Plus
What, no, who said no?
I'm just playing.
Plus the-
I thought you said 4 was greater than.
It's not.
Yeah, because it can at least be 4.
Here's the deal.
No, T is.
Here's, Maddie, here's what you're thinking. You're thinking if I wrote t is greater than or equal to 4, right? The problem is the 4 is coming before the t. So the 4 is less than or equal to t and t is less than 11. Because you're putting it in an interval notation or an inequality notation that has 2 parts to it, it's hard to see this.
So if it's.
But here's a rule of thumb, listen, if you know how you get this right. If you have an inequality notation, okay? If you have an inequality notation where there are 2 parts, and the x or the t or the a or whatever is in the middle, these signs should face the same way. They're never gonna face differently. The only time you have signs that face differently is when you have 2 different segments. Like if I had a graph that looked like this. If I had one where this was like a 5 and this was like a -3 and they both face this way, okay? That's when you're gonna have 2 separate segments where it says like x is less than or equal to -3, and then you would say like x is greater than or equal to 5. Those are that notation. If your notation, your inequality notation has the unknown in the middle, the signs have to face the same way. So start with whatever's easiest. For us, I think less than 11 was easier, yes? T's less than 11. So I know this sign has to face the same way, okay? Now, give a verbal description of each interval. How would you say this? What'd you say?
X equals -1, y equals.
X equals, no.
Uh,
These aren't X and Y points they're right now.
Oh,
They are written in inequality notation. So how do I read that in inequality notation for me?
Oh.
There you go.
-1 is less than X, and X is less than 0.
Okay, you're saying -1 is less than X is less than 0. Sure, you can say it in that one form. Okay, that's fine. So because it just wants verbal, that's all you have to do. You'd have to write it out in words like that. You're not writing it in this form, you're literally writing the words you tell me. Does that make sense? Give me an actual sentence. Yeah, this is gonna be English class. Okay, so, the interval consists of all real numbers that are greater than -1, less than 0. That's one way you could say it as well. Okay, this consists of all real numbers greater than -1 and less than 0.
That's not that many numbers.
No, it's not. How would you read this one?
It can be 2.
Good, you're on to something. This is an infinity sign. I wrote that real quick. So it can be 2, but it also what?
It can go all the way to infinity.
Good, can go all the way to infinity. So a way that I would word that is that the interval consists of all real numbers that are greater than
2.
2. Okay, how would I word this?
Greater than, that's the bracket.
Yes, greater than or equal to 2. How would I write this?
The interval
All
consists
real-
of all real numbers less than 0.
Okay, or all non-negative real numbers.
Yeah.
Either way is fine, perfect.
All the numbers.
All real numbers less than 0 or all non-negative real numbers. Okay, good. So you might have to write some things out. Now, we're going to do absolute value and then we're gonna stop after that. Okay, how do I evaluate absolute value? What does it mean when I have absolute value?
They are.
Yeah, okay, so whatever's inside the absolute value always comes out to be positive, right? So if I put a negative in there, it's gonna be a positive. If I put a positive in there, it's going to be positive. Because it's talking about a distance. Absolute value is a distance. How far away is that number from 0? Which is really what it's saying. So that's why it comes out positive, because you can't have a negative distance in this case. How do I evaluate the absolute value of x over x when x is greater than 0?
Whoa. You said a whole bunch of X's.
I did say a whole bunch of x's.
All right, say that again one more time.
Well, How do I-
value of the x, is 0 of 0 is 0.
Nope, I said when it's greater than 0.
So wait, what'd you say?
How do I evaluate
Evaluate.
the absolute value of x over x when x is greater than 0?
You evaluate X when X is
Infinity over infinity.
So don't make this harder, no, don't pick infinity, literally pick a number.
One.
17.
Beautiful, don't make it hard.
Tyler.
If I plug,
Specific number.
if I plug in 1, I have the absolute value of 1 over 1. What's the absolute value of 1?
One.
What's, so then what's 1 over 1?
What's the absolute value of 17
So-
over 17?
What happened there, okay? If x is greater than 0, and you're taking the absolute value of x over x, then you always are gonna get what out? 1. You're always gonna get 1 out, okay? What happens when you take the absolute value of x over x when x is less than 0?
Negative 1. Negative 1.
So if I do -1, the absolute value of -1 over -1, right? Absolute value of -1 is?
1.
And I have -1 over -1, which gives me?
Negative 1.
So when I take the absolute value of x over itself, and it's less than 0, it's always gonna come out to be a -1. That's what they're telling us. It's just a rule with absolute value, okay? So they're just showing us. So anytime they give you x's and give you a parameter, you can pick any number in that parameter to plug in. You all can pick a different number, it would still come out the same solution at the end, okay? Now, let's do this one. We're going to evaluate the absolute value of x plus 3 over x plus 3 when x is greater than -3. What number do you want to choose?
Cameron, would you like to do 2?
I wanna do
We'll
2.
do 2 then.
Okay, because 2 is greater than -3, so I'm going to say the absolute value of 2 plus 3 over 2 plus 3. What's 2 plus 3?
5 over 5.
The absolute value of 5 over 5, which gives me 1. Okay? Now, how about when you have x plus 3, the absolute value of x plus 3 over x plus 3 when x is less than -3?
Negative 5.
-5? -5 plus 3, the absolute value of that, over -5 plus 3. -5 plus 3 gives me a -2. I have the absolute value of -2 over -2. What's the absolute value of -2 over -2? -1, because that becomes positive. But yes, see how that works? When whatever is in the absolute value sign is the same as the denominator, you're going to get these solutions.
Wait, is it not always 1 and -1?
No, it's only when the absolute value matches what's in the denominator spot. Okay? And then on page 5, there are properties of absolute value, okay? The absolute value of A is always greater than or equal to 0, okay? Always greater than or equal to 0. We know that. That's a common sense rule. The absolute value of -A also always equals the absolute value of A. So if I have,
Always positive.
right, because if I take the absolute value of this, it's going to also equal the absolute value of that. Okay, that's rule number 2. We know that. We have a third rule. If I have the absolute value of A, B, it's going to equal the same thing as taking the absolute value of A, taking the absolute value of B, and then multiplying those answers together. Okay, because if I multiply them inside or if I multiply them outside of each other, it doesn't matter. And then the fourth rule is a fraction rule. Okay? And it's telling us the same type of thing. If I have the absolute value of A over B, it's the same as taking the absolute value of A over the absolute value of B, as long as B does not equal what?
0.
0. Okay? You know those rules, they're in your head. You just have to remember them. They're stuff we've done since pre-algebra. Okay? That's where we're going to stop today. And tomorrow we're going to jump into all the fun properties: commutative, associative, distributive, multiplicative. We have